My name is Madiane Andrade, and I'm the president of the Canadian Black Scientists Network, and I'm thrilled to welcome you today to Science as a Career Path, our panel discussion about different types of ways you might think about building science into your plans for the future. Now, I do want to start by just acknowledging the land on which I am currently, which is the University of Toronto. Welcome to my office at the University of Toronto, Scarborough. At the Canadian Black Scientists Network, we are committed to working in solidarity with Indigenous peoples to ensure that the calls to action in the Truth and Reconciliation Commission are acted on by us to the extent that we're able to, and by the Canadian government. So we are thrilled to be on this land, which, as you know, for generations has been home to Indigenous peoples who are still here and are still the caretakers of this space. Now, at the Canadian Black Scientists Network, we are committing to action through our programs to join with Indigenous people. And one of the things that we will be doing is having a panel during our upcoming conference to discuss the ways in which Blackness and indigeneity together can be considered intersectionally as we think about moving forward with justice in Canada. Now, I'm thrilled today to tell you a bit more about the Black Scientists Network and to let you know that we'll be having more panels of this type as the Scientists Network over time. And so essentially our network then, our goal is to make it easier for you to interact with us as a group and also as individuals, and to engage in mentorship for students and others in the Canadian context. So what I did want to share is that we are going to be having a conference from January 30th to February 2nd. It's our first annual virtual conference, the Black Excellence in Science, Technology, Engineering, Mathematics, and Medicine and Health. It will be held in a virtual context. It will include a wide range of different types of speakers, many of them public-oriented speakers. And I want to point out that that first day, January the 30th, is actually a Sunday. And we deliberately did that so that we could invite school students, high school students like yourself, to actually attend that conference with us. And it is free for all students. Now, one of the reasons for that is that we want to engage everyone from the earliest stages right up to professionals in listening to and thinking about science with us. This event will be bilingual, it will be accessible, it includes a career fair, and some of our career fair participants will actually be engaging in recruitment during that fair. It will also have a high school and middle school science fair, which I'm very thrilled to tell you about. So free registration for all students. If you want to learn more, take a look at the link that Tane will drop into the chat box, and that you can take a look at our website. The science fair is going to be our regional competition for students who want to go forward to the Canada-wide science fair. The Canada Black Scientists Network has a youth branch, which is a regional member of Youth Science Canada, and we'll be holding a virtual science fair that will start during our conference. Who can participate? Any Black identifying students in grades 7 to 12 from across Canada. And it's a great opportunity to develop research skills, showcase innovative ideas, and also meet mentors who are scientists from a wide range of different fields. We do this in a couple of phases. On January 30th, that Sunday that kicks off our conference, will be an opportunity to present proposals that you will develop into your science projects. You'll get feedback and you'll find mentors to help you develop your project. In phase 2, which will be held in April, you'll present your final project at the Canada Black Scientists Network Youth Regional Science Fair, and you'll be competing to represent us at the Canada-wide Science Fair, which is held in May. So it's a great opportunity to meet other students, to meet mentors, and to really engage with science. If you want to get started, have a look at the link below that Tane will also pop into the chat box, and that will get you started with your engagement in this project. So with that, I'd like to turn us to discussing what we came here to talk about today, which is to talk to our panelists about their exciting careers and to find out more about science as a career path. And today we are going to be, our session will be moderated by Dr. Tim Bardwell, who is a medical physicist at Dalhousie University. He's in the Department of Physics and Atmospheric Sciences and the School of Biomedical Engineering. He's a lover of music, of listening, playing, and dancing music, which I think is a great factoid about him. And I should have said my factoid, which is that I secretly love zombie movies. So you can be a scientist and be into a wide range of different things. So with that, I think I will turn it over to Tim, and he will introduce our panelists.
All right, thanks, Maydan, for that great introduction. And thanks for all the work that you're doing with the Canadian Black Science Network. It's a great initiative, and it's great to have your leadership in this initiative. So I'd like to introduce our panelists. So we have 3 panelists with us today. Olan is with us from Ottawa, and he's an environmental epidemiologist, which means that he studies and assesses the distribution, cause, and prevention of diseases. He's a research analyst at Stats Canada and an honorary research associate at the University of Cape Town in South Africa. And Olan and I discovered that we share a passion, which is the beautiful game, football, also known as soccer. So we both, well, he plays soccer every week in a league and is the lead scorer for his team. We also have with us from Mississauga in Ontario, Anna Ampaw, who is a postdoctoral research fellow at the University of Toronto in Mississauga campus. She's a chemist by training and studies chemistry, and is also the founder of the Empowering Female Minds in STEM program, which is a program that, amongst other things, funds scholarships for African women who are interested in studying STEM, so science, technology, engineering, and math. Finally, joining us from the Bahamas today is Nicola, Dr. Nicola Smith. She is a Liber Aero postdoctoral research fellow at the Changing Oceans Research Institute, which is at the University of British Columbia, and she's a marine conservation biologist and associate editor for Neobiota, which is a journal that studies the effects of invasion of non-Indigenous species from microorganisms all the way up to terrestrial animals, and the impact of these invasions on things like ecology, the environment, and even the economy. So welcome to all 3 of you. So I'll jump right into the questions, and I'm going to ask the first question to everybody. But I'll start with Olan and I'll work my way around the group. So many of our attendees today are students who are in their final years of high school and likely thinking about what comes next for them. So I wondered if you could share what you remember about what you wanted to be when you were in high school, and then explain what you do now.
Thank you very much, Sam, for such a wonderful introduction. Hi, everyone, and welcome. And when I was in high school, so quick fact, I did my high school in Nigeria, and having Nigerian parents, I did my high school in the early 2000s, and you were told there are just some fixed type of jobs out there. So you become a doctor if you love science, if you love biology, or you become an architect if you love drawing things, or you become an engineer, or you become a lawyer if you're in art, or you become an accountant if you love the business side. But we weren't told about the jobs that would be available in 2021 and beyond. We weren't told about the opportunities out there, the skills and the life that we can have beyond what the title of the job says. So I wanted to become a doctor because that's what everyone, a medical doctor. So let me differentiate. So I'm a research doctor now. I wanted to become a medical doctor, but I got into med school, and in my first year, I learned that being a medical doctor goes beyond just the name of being a medical doctor. I happen to be exposed to doctors and living with a medical doctor and seeing the life of the long hours and what it takes. And I was asking myself, so if I still want to do something impactful, am I ready to have long hours and have, night shifts and day shifts and, the different calls? And then today I'm an epidemiologist and a research doctor. Like, well, I can be a doctor in another way, going through the research route and doing my PhD. And that's what I do now. So am an environmental epidemiologist, so I look at how what's out there in terms of the disease and how to prevent it as well. And so right now I can say I'm still achieving my dream, the high school me is still achieving the dream, but in a different way, in a research way. And I think I would leave it at that, and interested to hear from my other panelists as well.
Thanks, Solon. Yeah, and as a medical imaging physicist, I can appreciate your perspective that you're still able to contribute to the study of disease, even though you're not a medical doctor. So that's great. Nicola, would you like to go next?
Sure. So I wanted to be a medical doctor. I actually wanted to be a pediatric oncologist, which is a doctor that studies cancer in children. But I learned pretty quickly in undergrad that I really didn't like physiology that much. And I didn't really like being around sick people, and I hated blood. So I realized that this probably wasn't the field for me. I love science. So no, I didn't become a medical doctor. I am actually a marine conservation biologist. And right now what I do is I study the interactions between invasive species, that are species that from different locations that show up in areas that they never occurred before. And I look at how they interact with climate change in our oceans. And climate change and invasive species are two of the biggest threats to global biodiversity, or the diversity of life on this planet. And I study the interactions between those two, and I'm really happy to do that. And I study it globally in all oceans, as well as in the 3 oceans that surround Canada.
Thanks. Isn't it amazing how you can start your university path or journey looking into one thing and end up doing something so different? Both Nicola and Alon, your stories resonate with that. Anna, what about yourself?
Yes, so hi everyone. So similar to Olan and Nicola, during high school, I was very flip-floppy in terms of what I wanted to do. I went from wanting to be a lawyer, then I wanted to be a businesswoman, and then I wanted to be a backup dancer, and then I wanted to be a doctor, but then I finally settled on a dentist, just because I was really into health and science. But just like Olan said, I didn't want the long hours of being a doctor and the kind of lifestyle. And being a dentist, you're still involved in people's health. However, it's more like a 9-to-5 job. So, you know, you're not on call, and you can have your weekends and your holidays and everything. So I settled on that, finishing high school. And so going into university, I made sure I chose a specific program that could kind of get me into dental school. So I chose an undergrad that was called biopharmaceutical science at the University of Ottawa, and I majored in medicinal chemistry. And so going through the undergrad program, I realized that I was pretty good in chemistry. Not that I loved it, but I was pretty good at it. And so I just kind of kept with it, still with the intention of wanting to be a dentist. So long story short, after several tries of trying to get into dental school, and then even going to do a master's in chemistry to kind of better my chances to go into dental school, tried again after my master's, I still didn't get in. And then I realized that I actually loved chemistry and I loved what I was doing. And so I decided to further and do a PhD in chemistry, and to the point where now I'm doing a postdoc. And so I've kind of come full circle back to medicinal chemistry. So kind of back to what I started with in undergrad. And I actually really love it right now. I couldn't imagine myself doing anything else. In terms of what I do, I'm still involved in health, but more at the elementary stages, where what we're trying to do is we're trying to make different drugs and different molecules that will interact with proteins that have therapeutic value. So a lot of times diseases are because of, there could be a malfunction genetically, or there could be a malfunction in your body with one of your proteins. And so if we're able to fix that malfunction with different inhibitors or different compounds that we can synthesize, then you can treat the disease. And so that's pretty much what we're doing right now.
So Anna, I just want to follow up on that. One of the things you said is that you're making the drugs. Like, so I'm just trying to imagine what it's like. Maybe you can share with us, what does it mean to be a postdoc? Like, what is that? And then what do you mean when you say making drugs? Like, are you like actually making compounds like in a lab, like with a white coat and all that?
Yes, yes, exactly. So to answer your first question, so to be a postdoc, so postdoc is similar to being in graduate school, just in the terms of you're working in a research lab, but you're no longer a student. So you're actually considered an employee of wherever you work. And so I'm considered an employee of the University of Toronto because that's where I do my postdoc. And so pretty much my day-to-day life is I go into the lab and I do a bunch of experiments. So if you guys have ever taken organic chemistry in grade 12 or any chemistry course, you know that pretty much the world is made of molecules and made of atoms. And so essentially, when I say we're making drugs, it means that we're putting atoms together and reacting different compounds and molecules with other molecules so that we can make an organic molecule that we can use to treat a disease. So for example, I'm sure everyone has probably taken Tylenol once in their life or aspirin once in their life. So Tylenol and aspirin, they actually both started in a lab, and it started by a chemist mixing molecules and putting molecules together to make a drug that will treat a certain sickness in humans.
Cool, thanks. That's really neat to hear about. Nicola, you mentioned that you had been working on, you're also doing a postdoc, but in the area of invasive species. I wondered what drove you towards that area of science, and then also what made you want to be just a scientist in general?
So I'll start with the last question. I wanted to be a scientist because I was always fascinated by the natural world. I always wanted to understand how organisms interacted with their environment and with each other. And simple things like if you looked at a plant and why was some parts of the leaf white while other parts were green, that's called a variegated leaf. I was just always interested in nature, and biology was always my favorite topic, my favorite subject in school, biology and English, actually. And so I just wanted to study biology forever, quite frankly. And the way to do that was to be a scientist. As opposed to just reading about how animals interacted with the environment, I can actually study them and create the knowledge that people will then read about, but also in terms of use that knowledge to solve real world problems in conservation that we're having in the world. And in terms of why I study invasive species, well, that actually has to do with the fact that I'm from the Bahamas originally. So I was born and raised in the Bahamas. And at first I was just interested in marine biology because there's lots of ocean. We're a small island state and I love to snorkel a lot. But when I was snorkeling after undergrad, I worked for a year at the College of the Bahamas Marine and Environmental Studies Institute. And I was just doing native fish surveys on coral reefs. And on every reef I went on, I kept on seeing this big, brightly colored fish with red and white stripes with these big fan-like fins and these spines along its back. And it wasn't from the Bahamas. And I read about it and I realized that it was from the Indian and Pacific Oceans and that it was actually an invasive species in the Caribbean, which means it kind of came from the Indian and Pacific Ocean, was released into the Atlantic Ocean by people in the aquarium trade because it's a really popular fish in the aquarium trade. And it kind of just took over. It started reproducing and just spreading throughout the entire Atlantic. So it's found as far north as North Carolina in the US, or as far south as Brazil. And I wanted to know what sort of impact was this fish having on native communities of fishes, because there were so many of them. They were everywhere, but not just everywhere, but they were so abundant. And so I thought they must be having an effect. And I wanted to know, well, what sort of effects are they having? And so that's how I ended up into biological invasions. And from there just led to another species and another species. And then basically into how is it that some species show up and have these catastrophic effects on the environment, and then others kind of show up and they're completely benign. And so I wanted to know what sort of processes and factors and characteristics drove these sort of patterns that we would see. And then also how can we mitigate or lessen the negative impact that these species were having in native communities. And so, yeah, it started out by a pretty fish on a reef where it's not supposed to be.
That's a lovely story. Thanks for sharing it. And I love the number of questions that you had. And I think this is one of the things that defines scientists is that if you're asking a lot of questions, you know, maybe science is for you. You know, you see the fish and it immediately sets off a list of questions that you need to know the answers to. And maybe those answers don't even exist yet, and you're going to be the one to find them, which is the exciting part. So that's really cool. So Alon, what about yourself? What made you sort of, I mean, you talked about discovering that medicine wasn't for you, but how did you discover that science was the path, or that research was the thing that was your passion?
Thank you very much, Tim. So like Nicola and Han, I also found my passion for research as a kid growing up. If anyone have been to Lagos or heard of Lagos, Nigeria, you know that's 20 million people living in one city. It's a densely populated city. That's where I did my formative years. And I realize every time I go out and I'm stuck in traffic, I come home with watery eyes, and I have a bit of a headache and migraine, and I kept asking myself, is it due to the stress of the traffic, or there's something in the air? There's something in the air that I can't see and I don't know about. So that was a lingering question in my head. And when I moved to the UK, the smoking rates there were so high that I kept asking myself, so if you're smoking next to me and I don't smoke, what are my risks? And what is the risk to kids of parents or guardians who smoke and who don't have a choice than to be in the same environment? And then I did my master's in public health, and I researched the health effects of secondhand smoke, passive smoking, just being around someone who smokes, and the health effects on children and infants. And then that led me to my PhD, which answered my first question when I was younger about the effect of air pollution on children's health, looking at respiratory health. And that was about the same research I went on for my postdoc as well when I was on my postdoc. And luckily for my day job, can you imagine how beautiful that is? I'm still researching around the same topic. So it means for my day job, I'm getting paid for something I love doing, or a question I love researching. And then it's fascinating that some of the research that I and my colleagues have contributed to have actually informed the WHO revision of the guidelines on ambient air pollution. And it gives me personally a fulfillment, and also being able to contribute to the knowledge of science. So it did start at my formative years. And I just wanted to tell the students listening right now that if you do have questions like Nicola, like Han, like I do have, write it down and have it somewhere, and think about ways that you can answer these questions. You don't have to change the world, but just one question can actually go a long way in pursuing your path in research and science. So that's my journey, Tim.
Thanks for sharing, Alon. That's a great story. I love the way that you talk about writing as an integral part of being a scientist. And Nicola, you mentioned your joy of English as well, and how much you spend so much, we have to read a lot to learn, and then write down our ideas to share with others. So the importance of those things are key. I just should mention to our attendees, to the audience, if you have questions that you'd like to ask our panelists, we're going to switch to audience questions towards the end. So please do add them in the Q&A. There's a button at the bottom of the Zoom window that says Q&A, and you can post your questions in there. You can also vote up other questions. If you like a person's question, you can like it, and then it'll be more likely to be asked. So do go ahead and do that. So I'm going to come back, Anna, to you. I wanted to ask sort of about your work experience as a postdoctoral researcher. What's maybe the most enjoyable thing about your work, or the most satisfying and what makes you proud to do your job?
Yeah, so the one thing that I really enjoyed, and I would say not even just my postdoc, because I just started, I'm actually new in my postdoc. I'm 3 months into it, but I've just come from graduate school. And like I said, it's a very similar experience. And the one thing that I really value about graduate school and doing research and postdoc is that you get an opportunity to contribute to a field that you're interested in. Because a lot of times going through school, like going through high school and even undergrad university, a lot of times you're just learning what has already been discovered in a certain field. So you go to class, you learn things, and then you write a test, and you kind of like regurgitate it on the test. But the cool thing about grad school is that you can research into what you actually love. If you have questions, you can pursue those questions and discover things. And then on top of that, you can write it up in a journal article and then publish it so that everyone else can find out what you discovered. And so I think that's probably the most fulfilling thing, knowing that you're contributing to a field that you love, and also you're discovering new things and adding to, you know, a field that you're interested in.
So could I ask a follow-up question, and you don't have to answer if you don't want to, but what publication, or I guess what of your own scientific work are you most proud of that you've done like through your graduate studies?
So I would say, so my graduate studies, it was a little different from what I'm doing now. It wasn't specifically medicinal chemistry, but it was cryobiology. I'm not sure if anyone knows about cryobiology, but if you know of Captain America, and his superpower is that he can freeze himself and then come back to life afterwards. So we're kind of doing the same thing, but not on like the human level. We're trying to see how we can better preserve, you know, cells and tissues and organs, just at that level. And maybe eventually we'll work up to a whole organism, but we're not there yet. And so my graduate research was pretty much on how can we make molecules to better preserve different cells. And I was looking into specifically red blood cells, and a type of stem cell as well. And so one of the papers that I published was that I found that there was this one molecule that I made that was able to better preserve a type of blood cell. And also it was really soluble too, because again, with a lot of the molecules that we've made, we've had solubility issues, which is not beneficial to what we're doing, just because you're pretty much dissolving it in water, and you want to have a high solubility so that you can dissolve more of your compound in water, so that'll be more active towards your goal, which is improving cryopreservation. So yeah, so I discovered a molecule that was able to have a high solubility and also was able to cryopreserve different red blood cells.
Were you able to call it the AMPA molecule, or? No?
Yeah, no, we have to call it by its molecular name.
Oh, I see. Okay.
Yeah, I wasn't able to put my name on it, unfortunately.
That sounds like science fiction. It's really amazing.
Mm-hmm.
Olan, I have the same question for you. I guess, you know, what are you most proud of, or what makes you, you know, enjoy your work?
Thanks, Dean. I think the most satisfying part of my work is being a public servant, serving the Canadian public, and not just the Canadian public, and serving the Canadian public and beyond, because I'm involved in research outside the shores of Canada. Like I said, I'm a research associate at the University of Cape Town, where I mentor and teach and also supervise graduate students. The most satisfying part of my work is, like I said earlier, is knowing that the work I do is having an impact in policy in terms of informing regulations, where we look in closely. The smoking ban in indoor places is a good example of how some of the research work around that I've done and other researchers in that field has done have actually led to stricter regulations of smoking indoors, of smoking in closed environments, and also smoking in public spaces as well. When we looked at air pollution type of research, exposure from traffic-related pollution, you see they move to a greener economy, right? That's happening now. The electric cars and greener type of technology, these are all informed by research that folks and scientists in my field are doing. And just doing that and knowing that you're contributing to real-time science, not something to be seen in 20, 40 years, but something that's informing policy of tomorrow. It's really very satisfying for me personally.
Yeah, I mean, it reminds me of, you know, the example of smoking is amazing, because I remember being a young person and, you know, sitting in restaurants and everybody's smoking, or the coffee shop, and it's just a cloud of smoke in the place. And we all just thought it was a normal thing, but it was actually science that told us that we were actually harming each other and the staff and everybody. So yeah, that's a great example. Nicola, I wanted to ask you about your career path. You know, we follow our passions, but of course there's always challenges along the way. So I wondered if you experienced any challenges or barriers to your career in science, and how you overcame those.
Well, for me, like I said before, I'm from the Bahamas, but I did all of my undergrad and graduate career and postdoc in Canada. And one of the biggest challenges, so I was an international student, and one of the biggest challenges to being a scientist, if you're an international student, is finding funding for your research. Because the Canadian government has this thing called NSERC, and they fund Canadian citizens and residents to do research in university, because that's a great thing. Like in university, you actually get paid to do research, which is really cool. And they also pay for your research. So you get a salary, and then you also get money to do the things you need to do. But if you're not a citizen or a resident, then you're not eligible to access that money. So for me, the biggest stumbling block that I had to overcome was, how can I get funds to do the work I loved, to A, pay myself, and then B, fund my research. And so what I did was, there are lots of grants out there, like so lots of organizations that finance research, finance scientists and finance just scholarship. And so I wrote to lots of different funding agencies. Some were national, so some are from the Bahamas. Some were international, like the Organization of American States. Some were regional, like the Bullitt Environmental Prize, which basically funded research and scholarship for anyone that did sort of environmental work in the Pacific Northwest. So what I had to do was, I had to be really creative and really resourceful, and I had to write a lot of grant proposals, and I had to put together, because usually one fellowship is not enough to, or one set of money is not enough to get you through like the entire 5 years, 6 years of your PhD. So you need many of these. And so every year or two, I was always writing for more and more money. And at the time, it felt like an incredible setback and disadvantage, because I had to spend so much time into writing grant proposals when other people didn't have to, my colleagues, my peers didn't have to expend this energy and this time looking for money. They could just focus on their research. But what happened at the end of the day, like now that I'm a postdoc, is incredibly beneficial, because what I learned was, I learned the skill of writing grant proposals, and I became really, really good at it. And the thing is that when you're a scientist, particularly like, you know, because I want to go on to be a professor, but even if you're not in that position, if you're in a research lab or something, you have to know how to write grant proposals to get money to fund your research. And so this is a skill people don't really learn how to build until much later in their careers. Whereas I learned how to write grant proposals from the very first, year of my master's degree. And I became incredibly successful at it. And so much to the point that I was actually just writing an application for something, and then I realized that I'd raised over 400,000 Canadian dollars just in my master's and PhD degree for funding research. And when I think back on that, I'm like, wow, that's an incredible feat that I was able to do that. And as an as a graduate student. And so what can sometimes be an obstacle in the beginning can be a huge advantage in the future, because it builds resilience and it builds skill sets that are become invaluable for your career. So the international students funding is going to probably be your biggest challenge, but also it's going to be your biggest asset later on in life if you're successful at it. So yeah, I would say that was definitely my biggest challenge.
Thanks for sharing, Nicola. I know that as you continue on as a researcher, I'm sure that skill is gonna serve you really well. I know that telling the story of why your research is important is a big part of being able to do the work you want to do. So that's really great. I wondered also about the experience of coming, and you said you can get paid to be a student, even as an undergraduate student. So I know there's summer research opportunities that exist. And so many of the students in my department here, they study from September through the school year, but then they stay with us through the summer and they work in somebody's lab and they get paid for that. So it's, if you're a person who's interested in science, it's often a great first exposure. And I'm speaking to our attendees who may be thinking about, how am I going to afford to be a university student? You can actually very quickly get into getting paid to do the thing you love. So it's a great opportunity. I wanted to follow up actually about grad school, your experience of it, Nicola. You came to Canada to be a grad student, is that correct? Yeah.
From undergrad.
For your undergrad and
then grad school, and just kind of stayed.
So I wondered, and all of us, it's a part of the completing grad school is really part of the experience of the career path towards being a scientist, and often the first time we get paid to do science. So I wondered, what was grad school like for you, and if there's any fond memories you wanted to share from that time or things you enjoyed.
Oh, grad school was fabulous. Undergrad pales in comparison to what your graduate school experience is, because in undergrad, you're doing tons of courses that are prerequisites and things that you just kind of have to do to get to where you want to be. But once you hit grad school, you're just doing things that you love and things that you're really interested in. And then you're surrounded by people that are equally as passionate about what they're doing. So you're not just kind of going through the motions, you're actually like really involved in your work. And you finally get this whole spirit of discovery, because you get to do your own research and you get to come up with these new ideas, and you form new ideas, new questions, you get to answer those questions. You also do a bit of coursework, but it's not that much. Like usually I finished all my coursework within like my first year of my master's, and same thing with my PhD. Within my first year, I finished all the classes. And then the rest of the time is just spent developing your research project and asking those questions, figuring out how you're going to answer them, and then going on and answering them, and then writing up your results and getting them published. And the great thing is too, you get to go to tons of conferences. I got to fly all around the world and go different places I otherwise would have never gotten to go to, and on someone else's dime, which was like beautiful. And you learn new skills, because I didn't learn how to scuba dive well and become a scientific diver until I was actually in graduate school. And the great thing is that because I was a marine biologist, this was covered for free for me. So whereas if you're not in graduate school, if you're not, if you want to learn how to scuba dive privately, you have to pay something like $500–600 just for your first open water certification. If you're in grad school and you're doing marine biology, at least at the university I went to, that's free. So you just saved yourself about $600, and that's like $600 US in learning a new skill. And then from there, you just get many, because there are lots of different certifications in diving, you get more and more and more. And all of it is free. The only thing you pay for is your certification card, which is $20. So it's great because you develop all these new skills. You get to travel around the world. You get to meet lots of different people who are equally as interested or even more so interested in what you're doing. And the great thing about that is that your friends that you meet in graduate school become your professional colleagues later on in life. And so I find out now, even during my postdoc, when people have questions for me, I'm like, hey, I actually worked with someone during my PhD that studied that, and uses that system, I'll shoot them an email and see if they can kind of get back to you with an answer to something. And so you form these really elaborate connections and networks with people through time as you go through your degree. And yeah, I would say grad school was one of the best experiences of my life. That being said, there are some downsides to it. And one of the downsides are that sometimes I felt incredibly isolated at times. And that's because your research can be isolating when you get into the writing up stages. You're kind of just sitting down at your desk or sitting down at home writing your dissertation, and it becomes a very individual sort of process at that point. But before that, science is very collaborative. And then also kind of can be a bit isolating because as a person of color, as a Black person, I was the only Black person in my degree, in my program. Particularly throughout my PhD, through the entire 6 years, I was the only Black person in the department. And so I always used to joke with my friends and say, you know, people can always tell when I go to a lecture or a seminar or a course or not, because if I'm there, I'm the only Black spot in the room. And if I'm not there, that Black spot is missing. And so it was kind of funny because I'm like, people will always know when I'm there and when I'm not there because of that unique situation that I found myself in.
Right.
It also meant that sometimes I had different perspectives on things that I couldn't really get my peers to fully understand because, you know, the experiences, the background experiences and so forth were very different. So I'm hoping moving forward with a network like the Canadian Black Scientists Network that we can get more Black people in science, and so that you don't have to have that sort of isolating experience that I also had at times in graduate school.
Yeah, I think that's a pretty common experience, and that hyper visibility that you talk about is a challenging thing to experience in any environment for sure, but in a professional environment, it's very frustrating. Anna, maybe I could follow up with you. You just just finished up your graduate school experience. So do you have any memories that you'd like to share, and any or experiences that you'd like to share?
Yeah, so I agree with everything Nicola said. She literally just took the words out of my mouth. Grad school, it's a very interesting experience. I wouldn't say it's great to that extent, just because I guess it depends on the experience that you've had, but it's a different experience for sure, and it was enjoyable. And the reason why it was enjoyable, just as Nicola said, is because you get to focus on a work that you actually like, whereas in undergrad, you have to take a lot of different courses because you're under a certain program, and some of those courses you may not like. But with graduate school, it's a lot more specific. So you're literally just researching into a specific field that you're interested in. And so that's what's great about it as well. Another thing too is that it's definitely a different type of learning, and it's a different type of environment too. So when you start anything, you're always going to go up a learning curve. Even with my postdoc, yes, I'm still kind of doing the same thing, but I'm currently going up that learning curve because I'm in a slightly different field. And so going back to the first year of my PhD specifically, I would say that I really struggled just because of that learning curve, because I was learning a bunch of new skills. Again, I kind of switched fields from my master's to my PhD, just slightly, so different techniques and everything. But after that first year, things definitely get better. And the one thing that I really enjoy about grad school is that it teaches you life skills. And life skills that you may not necessarily learn anywhere else, just because, like Nicola said, it's very collaborative. So it teaches you how to interact with people, how to work in a group setting, work with different personalities. It also teaches you how to do public speaking because you're doing presentations all the time. Every single time you have to present your findings, either at a conference, in front of academics. So it really helps you with kind of articulating, your research and science. It teaches you how to write as well, because half of grad school is writing either grants, like Nicola said, or you're writing papers, you're writing your thesis, which is the largest document I've ever had to write. So that really helped with my writing skills as well. And so, yeah, I really enjoyed grad school because there was a lot of skills that I learned that I don't know where else I would learn those kind of skills. And it really helps you to be tenacious as well, because especially in the science field and when you're doing experiments, and I can speak for chemistry specifically, but your results aren't always guaranteed. Like, for example, sometimes I'll do an experiment one day, and then a week later, I'll do the exact same thing, like not a change, and it doesn't work. Excuse me. And it doesn't work out. And you don't really know why it doesn't work out, but it doesn't. But you just have to pick yourself up again and try again. And so the one thing that I really learned is just how to be tenacious and also how to pivot really quickly as well. So like I said, a lot of times things aren't going to work out, and you may fail at experiments. Like, for example, my first year of graduate school, I don't really have much to show for it because it was a lot of trial and error. But then you just pick yourself back up and you pivot into another direction, and you may start another project, or you may kind of look into something else that may work out. So that's the one thing I do value about grad school for sure. And I feel like everyone should go to grad school. I think it's a great experience all around, and you learn a lot. So I think it's very beneficial in many ways.
I really like one of the things you were talking about, which was talking to people. And, I think it's one of the things that gets undersold about science, that it is a community. One of my favorite things to do is to talk science with people. And who better to talk science with than other scientists, right? To talk about ideas of how things work and so on. So I really enjoy that kind of experience. Olan, I'd like to come back to you, particularly given your experience in epidemiology and the area that you're working in. In the time that we're living in right now, it seems like our culture, there is this questioning of confidence in science and in scientists as topic experts, and that this is almost pervasive in our experiences in the media and in our discussions around, say, the pandemic or climate change. So I wondered, for you, what's it like being a scientist today with this kind of underlying your everyday life?
Right, thank you very much, team. I think the pandemic is really showed us the gap in science communication, and I think that's really key. We scientists, we've been publishing our findings in articles, hard copy articles, for years now. In universities and academia, we've been appraised based on publication. We've never thought about the 99.9% of people who aren't in science, who consume information in 2-minute videos and 5-minute videos. We weren't trained that in grad school. We weren't trained science communication in grad school, how to communicate findings. If Pfizer were to say, our vaccine is 73% effective for a particular variant and 33% effective for a particular variant, what does that mean to the layman person? And always giving that information. So firstly, with topics like climate change and the pandemic, I think politicians should not be the one talking about science to start with, because think about it. If someone you disagree with is telling you something, you've already built a wall. So even if they're telling you facts, you've already built a wall. So that's why you have party lines and partisan lines across things that shouldn't be communicated by politicians to start with. So when I put on the TV and I see a politician talking about science, you're doing a disservice, because you've got other people not in you that doesn't align with your political views, and you're telling them something and about science as fact, right? And that would just tune out and not listen to you. So one, I think science communication on the part of we scientists, I think it's a changing landscape right now. Ability for me to communicate my finding to the layman. I've got friends who've got questions, and if I have to explain to my friend who is not a scientist about how you don't just get one information from a single study and say, oh, I saw on the news or I saw on the website that a single study said X is related to Y. Like how you don't just take that sort of study at face value. You look at the evidence, you look at the quality of the study, and you put all the studies together. I was trying to explain what meta-analysis is, for example, how you pull evidence together before you draw a conclusion. And so there is gap and there's work to be done. And topics like climate change and the pandemic has really exposed the gap in science communication. And yeah, I'm interested to hear what my colleagues, my other panelists have to say about it as well.
Yeah, I mean, nothing is certainly science is not apolitical, right? It's should be a part of political decision making, and so having that communication piece be done effectively is so important, and recognizing the nuance of science, right? You know, as you say, the idea of a meta-analysis is that it ties back to what Anna was saying, that you know you can repeat an experiment and get a different result. It's not always going to be the same, and so understanding that what is the variability in these findings and how much can we trust them is so important. I wonder, Anna or Nicola, did either of you want to comment on this topic?
I think Olan said it really beautifully. Just the fact that there's that gap and the pandemic really exposed the gap. And it's funny because I never really thought about it, how, you know, all of our publishings as scientists, they just go into academic journals. But then it's like, who reads the academic journals? Other academics. But there's still 99% of the population out there that doesn't read the journals. And so I think that's the one thing that the pandemic also showed us too, is how important science is. Because when this pandemic started, who did everyone turn to? The scientists, right? To try to develop a vaccine for the virus. So I think it really emphasized how important science is, and also, like Olan said, the work that we have to do with science communication. And I feel that if we had started that work prior to the pandemic, then that would have built the society's confidence in us scientists. Because I think that just at the pace that, you know, the vaccine was developed, and everyone has questions about, well, was it developed properly because of the pace and because it was put out very quickly? But if they saw in history that that has been done before, and certain things have been done like that before, then it would have built their confidence, you know, that, you know, this isn't just a one-off, like this is how things actually happen. So right. Yeah, I agree with everything Olan said. And I think that as a scientist, we have a lot of work to do in terms of just merging what we find out in the lab and what we publish in papers with what the rest of the population know as well, and how we communicate that to the population.
Right, and in the context of the pandemic, I mean, it's not just the scientists too. The scientists, of course, played an important role, but the mathematicians and scientists who supported the data analysis for understanding public health decisions, you know, the engineers who implemented technology changes, and so all down the line, you know, it was an amazing effort, a story that is being told already. You can find these stories about the amazing efforts of the STEM community during this pandemic. So, Nicola, did you want to comment on?
Yeah, I wanted to comment a bit, not so much on the pandemic, but on climate change. And it's because, like I said, I studied the interaction between invasive species and climate change in our oceans. And sometimes it's very frustrating because some people don't believe in climate change. And so when you're trying to communicate to them, not just that climate change is real and it's happening, but it's also interacting with these other global forces. And it's interacting in sometimes unpredictable ways. We're trying to build an understanding to somehow be able to better predict what's coming our way. So I find that a bit frustrating because the urgency of the matter is not fully appreciated, I think, by most people in the general public. And I find it a bit depressing, actually, because I know what's happening, I know what's coming, and most of it is not good news. And then you see politicians still arguing, does climate change exist? And I'm trying to say, whoa, these really big, bad changes are happening. We need to prepare for these changes. And we're still back at square one of the conversation, where is there change? And so I find that, I found particularly when I got into this field, because my graduate degree just looked at invasive species in the ocean. And then for my postdoc, I decided to combine climate change with invasive species. So you kind of took on another sort of global changer. And I found that when I was reading up in the climate change literature, I found it sometimes to be so depressing that I'd have to read a bit, stop, take a day off, read something else, and then come back to it, because what we're finding is so alarming. And then the fact that so few people know this or understand this. For instance, in the Caribbean, like, it's predicted that 90% of all coral reefs will be dead by 2050. If you speak to a lot of people in the Caribbean and small island states in the Pacific Ocean, so this sort of thing, many people don't know that. But many people's livelihoods are intimately tied to healthy coral reefs, whether it be through tourism or storm protection or food security. And yeah, it's really alarming. It's really depressing. It's
So can I ask then about that? You know, as you know, we've been talking about the importance of communication in science, and how we need to have conversations outside of our peer group, I suppose. So maybe more generally, as a marine conservation biologist, who do marine conservation biologists talk to if they want their science to lead to change?
well, so
Like, is it, do you need to talk to policymakers, or where are these discussions? What are these discussions?
you have to talk to policymakers, you have to talk to managers, environmental managers, you even have to talk to politicians, because sometimes the questions you might think are very important might not necessarily be the most pressing questions that policymakers or management people have. And so you have to have open lines of communication very early in the process, and then continuously going forward with the research, so that we are getting the biggest bang for our buck, that we're not just answering questions, but we're answering questions that have immediate societal impact. And that being said, sometimes I find, because like I communicate my science widely, not just within scientific journals, but I try to write in popular magazines and this sort of thing. But even then, when you sit back and you say, well, who reads these magazines? And then once again, it's scientists. Like, for instance, I just wrote an article on a study I did this summer for the Conversation Canada. And that's like, this magazine, online magazine, but it's read mainly by scientists. So I was really happy. They got 20,000 views, 20,000 reads in the first few weeks of this article coming out. But then you think about, okay, well, who are the readers? And then you realize, oh, they're just lots of other scientists. And so I think we need to somehow, we haven't really been taught how to speak beyond this, either scientists themselves or science literate people that, are very deeply involved in the science in some way or another. I think, and maybe, I don't think sometimes, maybe it's not the scientist's role to do that. Maybe you need specific communicators who specialize in mass communication to kind of take the message that scientists have and repackage it in a way that it's digestible for broader audiences. So yeah, we can't do everything, but what we can do is what we do, we can do it well. And then you need to bring other people on to kind of make that bridge happen.
In that collaborative spirit. Yeah. Hold on, can I ask you, in your role with Statistics Canada, how do you connect as a scientist to the public at large through that organization?
Thank you very much, Sam. Within Canada, we have various outlets that we have an outlet that is written in layperson language called The Daily. It's released every day. It's digestible contents type of research. We heavily engage in social media. We have a LinkedIn page, and we do have other social media outlets like YouTube and Facebook as well, that we communicate our findings in, and we try to. Speaking of what Nicola said, we do have a team in charge of communication and repackaging some of the research that we do and some of the findings in a digestible way. So within the agency, we do have outlets where these are really short, not lengthy, boring articles, but really short, straight to the point type of releases that we do for the type of work we do within the agency.
And are some of the things that you're studying, those questions, are they coming from the government as well? I mean, are you being asked to look into certain things?
Oh, so the interesting thing about my particular type of work is I'm a researcher within the agency. We do a lot of, we have some mandates within the government. We have mandates for environmental type of research, for example, climate change type of research. We also do a lot of collaborations with academia and universities within Canada and also internationally. So my group is involved in a large study that's looking at the effect of air pollution at low levels. So this is collaboration with universities like Harvard University in the US and also European universities as well. So we do a lot of collaborations with folks outside the government.
Very cool. I just want to move to audience question while we're here, and invite again, if anybody has any questions, to place them in the Q&A. So this question comes from Miss Matty, which is, and I'll maybe pose this question to Anna first. So despite not being a science teacher, I'd like to instill representation and passion for science in my students. What are some ways that you found your teachers in elementary and high school motivated and inspired you?
First of all, thanks for the question. That's a really good question. I think that for me, thinking back to the teachers that I still remember from high school or elementary school, the ones that stood out the most for me were the ones, I guess, that were more relatable and also tied things into the real world. Because sometimes I find that school can get very abstract, and especially with sciences, a lot of students will ask, okay, well, so why do we need to learn this? Like, how is this going to help us in the future? You usually get that questions a lot. So I think that if, high school and elementary teachers are able to connect what they're learning in class to the outside world and apply it to real life situations, then it can make science and it can make different subjects more digestible. And I think that in the long run, it will help students remember, that, oh, okay, well, I know science is everywhere now, so maybe there's futures in like that career, and there's different things that you can do in science rather than just being like going to med school or being in those professional fields as well. So, yeah.
Thank you. I'd maybe like to open the question up to Nicola and then to Alana as well, but maybe also expand it a little bit, beyond teachers, maybe who, if you wanted to include also, who were some of the people who've supported or inspired you to get to where you are. The saying that it takes a village to raise a child, or, we stand on the shoulders of giants to see. So maybe, yeah, Nicola, for you, who are some of those people, or maybe just one of those persons who's made a difference for your career path?
I would say what I did a lot as a child was I watched National Geographic and Nature and Discovery Channel, and that really created an awe in nature for me, of nature and of science. And so I found public television actually was incredibly useful at that. And like one of my favorite shows was Bill Nye the Science Guy when I was younger, and the Magic School Bus with Miss Frizzle, the science teacher that would take kids on these adventures where you would kind of go into the human body. The bus would shrink and you'd end up in the blood cells and this sort of thing. So I found that TV was actually a really big, played a really big part in my life, like educational TV programs in terms of.
Yeah, talk about science communication, right? That's
Yeah, getting you excited about science was definitely and then like, you know, even like beyond science, because like I said, I loved English as well. I actually did a double major in undergrad in English and biology because these were the two subjects I loved the most. And I would watch things like What's the Story, Wishbone, which is this little dog that would go back in time into these different books. And you know, and it was just into these like really big like literature, like really big books in literature, and he would go back in time as this dog and kind of act through things and reading Rainbow Butterfly in the Sky, I can go twice as high. And so, yeah, so I think TV really played a really big role in inspiring me to want to be a scientist because they made it fun, they made it relatable, but also they took me to places I would have never dreamt of going. But, you know, you could go if you just sit in your living room and watch the TV. And so really broadened my horizons.
Thanks. And thanks for sharing the songs too. It really brings those shows back so vividly to hear the songs again. Olan, what about yourself? Any people or experiences that have inspired you to your career path?
Yeah, well, like Nicola, I didn't watch a lot of TV as a kid because we had this black and white TV as a child that wouldn't really show things properly. So I didn't have the opportunity, but I'm sure our audience listening in, they have a variety of outlet to watch, you know, many more of those inspiring science shows and TV. For me, it's mostly my teachers as well, and my dad. So my dad, he was a mechanical engineer and worked with some of the automobile companies, and then I fell in love with physics because of its fluid mechanisms and things like that, and everything around us at home just became like a workshop where you just trying things. You put water in the fridge, and then it's ice, and you see the water outside the glass cup. You start questioning, how did the water in the glass cup end there? Or why do I have a spill when the water thaws from ice to liquid states? What's happening, you know? And when I hear cracks in different seasons of the year, when the doors are cracking, what's happening? Why is it tighter in this time of the year? And why is it looser in this time of the year? So all those things around us is just science, and, you know, those questioning and understanding cubic expansivity physics, and this is why this is cracking up in this time of the year when it's cold and warm. So my environment, my dad and my teachers actually kind of brought science to something I can see and feel. Oftentimes science is seen as something so distant, something where you have to wear a lab coat and goggles and things like that, but in actual sense, science is it's all around us. We can even feel it and touch it, and that was my love for science started.
Very cool. We can draw inspiration from so many places, right, to make us into who we are in the end. I wonder, maybe I'll ask you, Alon, just following up on that, you talking about this passion for science and these experiences as a young person, and then of course your career path, which was not a straight line, and so many of our career paths are not a straight line. You know, I'm one of the newest faculty members at my university, but I'm definitely not the youngest because I had this circuitous path to get there. So anyway, I wondered, you know, how, or do you have any advice for our attendees? Oh, there's a question here about advice, so that's great. I'll just ask this question then instead of my question from Nita Bernabo. What advice would you give to your 16-year-old self?
Well, the one thing I would say to my 16-year-old self is,
sorry, we'll go around with this question. Maybe everyone can answer it because we have about 4 minutes left, so we can split that amongst us. Anyway, go ahead, Alon.
Yeah, so the advice for my 16-year-old self is, think about what you want your life to look at as an adult, rather than the title that goes with what you want to do, because the title is actually less important than actually what you want your life to look like. What I want my life to look like now, I'm lucky it ended up that way, but this is something I didn't think about carefully as a 16-year-old. I wanted the flexibility to work on something I'm passionate about in the comfort of my home, because I'm teleworking right now, and I'm having time to spend with my 5-month-old daughter and watching her grow every day while I'm doing what I love doing. So think about what you want your life to look like, the kind of flexibility. If you love traveling, and if you want to spend time at home, the type of life you have. And then the title is actually less important, because then you can tie the title to it and find a way to match the type of lifestyle you want and the type of research questions you want to answer. Yeah, I'll just leave it at that because of time. Yeah.
Thanks, that's great. Nicola, what about yourself? Any advice for your 16-year-old self?
My 16-year-old self, I would say have an open mind, because I was just so set on medicine, and that's because that was the only thing I knew. And it wasn't until third year of undergrad that I discovered ecology and that field courses, and that, wow, people do this for a living. You can actually like discover nature, because, you know, I'd see these things on National Geographic, and my friends would say, yeah, but that's for like rich white people in North America. You don't see any Black Bahamian girls, you know, on TV doing those sorts of things. And so I kind of like, although I liked this area, I didn't envision me in that role. Because, you know, I didn't have as broad a mindset. And so I think I loved, I don't remember the name of the actress right now, but she was in 12 Years a Slave. She became really famous. I think she was from Nigeria, maybe. Oh, no, Kenya. And she said, we shouldn't be limited. Our dreams should not be limited by our circumstances. And I think that that message really resonates with me now. So see yourself beyond your immediate environment, and yeah, really go out there. And Lupita, there we go. Yes, yeah, have an open mind and dream big, and it can still happen. Don't let people discourage you just because they've never seen it done before.
That's great. Thanks, Nicola. That's amazing advice. And Anna, what about yourself?
So I would just say don't stress. I find that when I was around 16, I just stressed way too much, and I thought I had to figure everything out just about my life. And like 16 years later, I'm still figuring it out. I still don't even really know what I want to do, like, because there's just a lot of opportunities. So similar to Nicola, I would say keep an open mindset. Know that there's a lot of opportunities, a lot of things that you can do. Just focus on what you love to do, I would say, and focus on what you like, and just kind of go about life by going by what you're interested in and what you like. And in terms of what the end goal is, you may not know at that time, and you may just end up somewhere and then realize that, oh, this is actually what I wanted to do all along. So I would just say, just calm down, don't stress.
That is all excellent advice that I could use actually as well. So thanks to all of you for that. I think we're at the end of our time. So I just wanted to thank our panelists again, Olan, Nicola, and Anna. It's been amazing to have this time to speak with you and to hear your stories. The CB, Canadian Black Science Network, will be hosting this conference about Black excellence in STEM. And you are all examples of that Black excellence. So it's really amazing to have this time to speak with you. So thanks a lot, and thanks to our attendees. Thanks for the questions as well, which were really great from our attendees. And again, thanks, Midian, for organizing this. I'll hand it back to you.
Thanks so much, Tim. You thought you were done, but you're not, because we do have a couple minutes. And Tim, I would love to ask you, I told you you'd be done now because I knew you wouldn't have a chance to answer any questions. I know, Tim, you've had an indirect route into your career as well, as you alluded to. And can you just tell us a couple of things? One is, what sort of made you end up where you are now? And can you give a bit of advice to our listeners about what it means to have a path that, as several other people have said, isn't always linear, and that you have to allow yourself to be flexible to go in the direction that I guess your heart is pulling you?
Yeah, thanks. That's a great question. I think that, from a young age, I knew that trying to understand how things worked was what I was interested in. Understanding how things work, finding the answers to questions that I didn't know, or maybe I asked my parents and they didn't know, and I would try to figure it out. And that was really a driving motivation. And I think that just remained true throughout. So at university, I had an interest in physics, but I also had an interest in philosophy as well. Trying to understand how logic works, how ethics works as well. So just really asking questions. And when I at the time didn't really know, because I'm not really, my family isn't like, they're not all professors or anything like that. So I was just kind of learning as I went along, and discovered that there was this thing called grad school, or actually it was summer research that I discovered. That was an opportunity to get paid to be in a lab and try to figure stuff out. My boss didn't know the answer. I had to figure out the answer. And that was so empowering, and really what I wanted to do. And I knew that was the path for me. So I did a master's, but then I left academia and I worked in industry. I thought, because there's more to life than just studying or just learning, and I wanted to experience other things, travel and fall in love and all of those things. And so I had that sort of real life, and had given up actually on being a professor. And then an opportunity arose, and I was fortunate enough to get it. So you never really know where things are going to go, but I think, as Anna said, I followed my interests really, and I knew that as long as I was doing something that I enjoyed, I would be happy. And that no matter how much I was getting paid, if I was doing something that I didn't like, I wouldn't be happy. So it was really just pursuing that happiness that led me to where I am.
It's a lovely note to end on. Thank you so much, Tim. I appreciate that. I think we're coming close to the end of our time. I have to say that I really am very appreciative to the folks you see on the screen here for being willing to engage in this, our first effort at a career panel. I think it was fantastically successful. I love that in addition to talking about what you do and your passion for it, you talked about life. You talked about how to maintain your mental health, how to keep your spirits up, and that sometimes your spirits wouldn't be up, and that you can get through that as well. So I hope there's some things everyone in the audience can take away from this. So thank you so much, Nicola. Thank you, Tim. Thank you, Anna. Thank you, Olin. And I also want to thank the people behind the scenes, Mariam Rubab and Tane Sharma, who are students who are working with the Canadian Black Scientists Network and helped to both organize this. It was Tane's idea in the first place, and he and Mariam worked to pull it off. So thank you so much for that. We really do hope that we'll see you at our conference, January 30th to February 2nd. It is free for all students, free. We've done a lot of fundraising so we could do that. It will be bilingual. It will have accessible supports, and it's going to include everything from high school science fair projects right up to top-notch, world-renowned astronomers and biomedical researchers talking about their work. And I will be remiss if I didn't mention the career fair, which Olin has worked very hard to organize. There will actually be some people there who will be screening applicants on the fly for positions in their organizations. So tell your friends who are looking for jobs in STEM, tell your students who are looking for inspiration to join careers in STEM. And we hope to see you there. Check us out at blackscientists.ca. Thank you so much for being with us today. Bye-bye, everybody.